All right, boys and girls. Welcome to day 2 of graphs of sine and cosine functions. So today I'm starting with example 6, and I'm doing the extra example 6. I actually don't like the checkpoint um on the example, and I don't mind it, but I feel like the answer is wrong. Okay, so I'm not going to do that one at all, and I'm going to hold off on you guys doing that one. Okay. So let's start with example 6. And example 6, basically what they want from you is to use a graphing utility to analyze the graph of y equals 4 minus cosine of 3x. Okay. And we can totally do that, but I want us to do as much as we can without a calculator, and then I'll show you how to utilize a calculator. Okay. And in example 6, they introduce vertical translation. All right, let's get started. Okay, as you can see, I wrote the like the general form right above. So y equals d plus a cosine of bx minus c. And hopefully you can tell they're different colors. I color coded them because remember they all represent something different, and I've introduced them slowly. Okay, so remember, A represents your amplitude. It's basically your range, how far you go up and down. B gives you your period or helps you come up with the period. C tells you how it shifts horizontally to the left or to the right. And then today, D is going to help you with vertical translation. Okay, basically how far it moves. It gets shifted up and down. Okay. So again, let's kind of just begin with the basic stuff that we can do on our own without a calculator. So here we go. So A here would be -1. But if I take the amplitude, it would be still 1, okay? But here's the deal. Today's going to get shifted because now there's a shift. So it's going to be shifted up and down, okay? So because there's a shift, we're not going to include our range. But just remember that the amplitude is still 1, okay? So amplitude, oops, sorry, I hit the camera. Amplitude is 1, so that will still stay. In the past, we didn't have a vertical shift, so it was just the range was always the same, okay? But ignore that for now. We'll just stick to this. Amplitude is 1. And then the fact that it's negative, that means this is kind of like an extra set of information, but you should know that. It means you're going to have a reflection, okay? So normally the way our cosine looks like, we're going to have a reflection, okay? And normally it would be across the x-axis, but since we're going to be shifting it, it'll be reflected a little bit different, but just reflection, okay? And then B is 3, and so that's going to help us find our period. So don't forget that the way you find your period is 2 pi over B, which is 2 pi over 3. Okay, so that's our period. So I know some people were wondering, what is our period for? It helps us find our interval because remember your period is like your domain. So it's one full cycle. So we know we're going to start at 0 and 2 pi over 3. You'll notice in the book they'll ask you to graph 2 full periods. So this will give you 1 full period, okay? So if you want 2 full periods, you just keep going, okay? So from here to here, it gives you 1, okay? So 1 cycle or 1 full period, okay? Now, you're going to start at 0 and you're going to end at 2 pi over 3. So now let's get all the key points in between, okay? Oh, and by the way, there's no C, so that means it doesn't get shifted left or right, okay? So, and then we'll talk about the D in a minute, okay? So let's get all the key points in between. So the way you get your key points is we know it's going to start at 0 and at 2 pi over 3. So just take 2 pi over 3 and divide by 4 to get all those key points in between, okay? Which is the same as saying, whoops. It's the same as saying 2 pi over 3 times 1/4, or 2 pi over 12, or pi over 6, okay? And basically, pi over 6 is going to help us get our increments. So ready? All right, let me show you the next part. Okay, so remember, we're starting at 0, and then we took the period 2 pi over 3, and we divided by 4, and we got pi over 6. So now we're going to add pi over 6 to 0 to get all our key points. So our next value should be pi over 6. Our next number should be 2 pi over 6. Our next one should be 3 pi over 6. And then our next one should be 4 pi over 6. Now, if you're wondering when do you stop, remember your intervals from 0 to 2 pi over 3. So pi over 6, 2 pi over 6 is the same as giving me pi over 3. 3 pi over 6 is the same as saying pi over 2. And 4 pi over 6 is the same as 2 pi over 3. Okay? So you know you're done because 2 pi over 3. So these are our 5 basically coordinates or key points. Okay? So again, I can find all of this without a calculator. Okay, now to get all our values or all our points, then I'm just going to utilize the calculator. So let me show you. Okay, so all I did was plug in 4 minus cosine of 3 x, but instead of x, we're going to plug in our values. Okay, so for the first one, it's going to be 0. So my first point is going to be 0, 3. So this point will be graphed at 0, 3. Okay, and then I'm going to press second and enter, and it's going to bring me the same equation, but now I'm going to change that 0, and then we put delete, and now I'm going to replace that with pi over 6. So pi over 6, okay, and that'll give me 4. So my next point, pi over 6, is going to be graphed at 4, okay? And now the next one, okay? Remember, we got pi over 3. So let me just change the 6 to 3, and we get 5. So pi over 3, 5, okay? And then the next one should be pi over 2. So that'll be at 4. And I ran out of room here, so I'm going to put it here. Pi over 2 and 4. Okay? And then the last one, 2 pi over 3. So 2 pi over 3. And that's going to be at 3. So 2 pi over 3. Okay? All right, here's the next part. Okay, so for the next part, we're going to go ahead and graph it ourselves. Again, they're not asking us to, but I'm just showing you so that you're able to do it on your own, okay? And then we'll take a look at it in the calculator and make sure we're doing it correctly. Okay, so I went ahead and plotted our intervals. So 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. So if you recall, at 0, I made mine every 2, so that way I can have a nice stretch. Otherwise, my graph would be really small, okay? So let me use a red. At 0, we should be at 3. So 0, 3, okay? At pi over 6, we were at 4. At pi over 3, we were at 5. At pi over 2, we were at 4. Okay. And at 2 pi over 3, we were at 3. So that should be here. Okay. Okay, so basically it will look like this. Okay, so basically it will look like this. Okay, and this is one full cycle. Normally, it would have been going down and then up, and that would have been a full cycle. But this time, remember, it got reflected, so now it's starting off low and then it's going up and down. Okay. Sometimes they might ask you to do 2 full periods, so I would keep this going. Um, so I could extend it maybe. Let's try that. Okay, so to get 2 periods or 2 cycles, I went ahead and just added the negative versions of these. Oops. And so now to get more points, so you could see more of a bigger window, I guess, or more of this cosine, okay? So basically, we're going to do the exact same thing we did earlier. So see, I have 4 minus cosine of, let's start with negative pi over 6. So I'm going to put negative, make sure you use the negative and not the minus, okay? So this will give you 4. So it'll go back up to 1, 2, 3, 4. Okay, sorry. It'll go back up here, okay? You can probably already get the pattern. You can use the calculator or just keep going with the pattern. So we started at 3 and then 4, and then our next one is going to be 5, and then our next one will be 4. So 4 would be here, and then our next one will be 3. So 3 would be here, okay? And basically it'll look like this. So if they want 2 cycles, it'll look something like this. I mean, you can do dot, dot, dot because it's going to be continuous, okay? But this would be like 2 cycles, okay? All right, now remember, I basically got all of that without even graphing on my calculator, okay? I don't really need a calculator. I can get that without. But now to confirm that I graphed it correctly, I can use my calculator. So y equals, if you notice, I already put in 4 minus cosine of 3x. And then for my window, I'm going to put 0, but I'll show you I'll mess with it a little bit later. So I'm going to start with 0. I'm going to do the first one that I did. My x max, remember we stopped at 2 pi over 3. So this is 2 pi divided by 3, okay? And then our scale, if you recall, we added by pi over 6. So for the scale, I'm going to put pi divided by 6. And then my y minimum, the lowest I'm going to put at 0 because we're not going to get any negative values. And the highest was 5, but I'm going to go ahead and put 1 more. So 6. And the scale there will be 1. Okay, so I'm going to go ahead and graph that. And this is what we got. And this is what we had earlier. Okay, so we did it correctly. Okay, this is what it looks like. So now I'm going to want a bigger window. Okay, so now I'm going to write I'm going to go to the window. And now for my x minimum, I'm just going to put negative 2 pi divided by 3. And I'm going to keep everything else the same. And now just put graph. And now you'll see like a left side and a right side. Okay, and that's it. So now, how did it compare to just negative cosine of 3x? So let's take a look. So y equals, and now just negative cosine of 3x. Okay. See, in the above, I use a minus, but we had a value there. And the second one, negative cosine of 3x. So we're going to compare this one to this one. So something happened, and we're going to see the red one now, okay? Here we go. Oh, see, it's further down. So I'm going to open up my window a little bit. So now I'm going to go to window. For y min, now I want some negative values. So I'm just going to put negative 2, and I think that's more than enough. If it's not, I'll just change it. So my lowest point here in the original is negative 1. And if you notice, it moves up. So there's a vertical translation. It moved up. How many units? So look, 1, 2, 3, 4. And that's the 4 in the front. It's a vertical shift. So, Oops, got smeared for flipping it over. So on top of everything that I found, this 4, which is the lowercase d, it's a vertical translation and it shifted up 4 units. Okay. All right, awesome, guys. So again, hopefully today it'll help you with the previous stuff. Okay. Let's see if I can find one more example. All right, boys and girls, I figured I'd try another one. And so the one that I'm going to try is number 53, page 300. And the directions are sketch the graph of the function, use a graphing utility to verify your sketch, and include 2 full periods. So they do want us to sketch it on our own and then just to use a graphing calculator to just verify it. Okay, so I kind of like this one. If you feel like comfortable enough where you can get started and you don't need another example, you can always fast forward, okay? But I'm going to go ahead and do this one with you. Okay, so let's start writing everything that we know, okay? So here we go. Amplitude. And I'm going to go a little bit faster and hopefully you understand. Remember, amplitude is your A. Your A should be here and it is 1. But it'll be -1. So it is going to be a reflection. So remember how sine usually goes. So just when you draw it, remember it should come out as a reflection. So if you compare it to the original parent function, it'll be a reflection of that. Okay. All right. B happens to be 2 pi over 3. Okay. This is another one where there's no C, so it's not going to be shifted left or right. Okay. All right, here we go. You know, D is 1, so that means it should be shifted up 1 unit. You already know that. Okay. So when we graph the parent function of this one, you should see it. Okay. So B is 2 pi over 3. So let's figure out our period. Okay. So our period should be 2 pi over 2 pi over 3. Which is the same as 2 pi times 3 over 2 pi. And the 2 pi's get canceled. So our period should just be 3. That means when we graph it, we'll graph it from 0 to 3. Now, I believe they want 2 full periods. So we'll go from -3 to 3. Okay, but for now, we're just going to write that. Okay. And then remember to get all the points in between, take 3 and divide by 4. In this case, I mean, if you want to write it as a decimal, you can, but you could just write it as 3/4, okay? This will help us find all our key points. So here we go. So we're going to start with 0. Then we're going to add 3/4, so that our next value is 3/4. And then we're going to add 3/4 to that. So that'll be 6 over 4. And then we're going to add 3/4, and that'll be 9 over 4. And then we're going to add 3/4, and that'll be 12 over 4. Well, these two values can simplify. This can simplify to 3 over 2, and this can simplify to 3. So that's a full period, okay? And now we can get our values using our calculators. So 1 minus sine of 2 pi, and then times x, okay, and then our first x will be 0, so times 0, then, divided by 3. And that gives us 1, okay? I'm going to keep doing that off camera just so I can go a little bit faster, and I'm going to find all our points. Okay, so off camera, these are the 5 points that I got. And so now we're just going to flip it over and graph it in the back. Okay, so I went ahead and plotted my points. So these are my intervals and these are my points. So basically it's going to look like this. Okay. And I can repeat the same cycle on the other side. Okay. So, negative 3/4, -3/2, -9/4, and then -3. Again, you can find these values in the calculator, but you can just go with the pattern because I think you have enough to find the pattern. So this one was at 1. So the next one will be at 2. So let's see, 2 will be here. Then the next one will be back at 1. And then the next one would be at 0. And then the next one would end at 1. Okay. All right. Sounds good. Again, you can kind of keep the pattern going. Okay. So this is what it's going to look like. Okay. So we know all these things again without a calculator. And so now let's use a calculator to just verify that we're correct. Okay, I went ahead and plugged in the function, and then I'm at the same time actually going to plug in the one without the shift so you guys can see the difference. So math, the parent one, I guess, of this one. 2x over 3. Okay. Basically, where everything's the same, it's just not going to have a shift. So that way you could see the shift. Okay. So now let me go to window. Okay. So I'm going to go with our values. Okay. So our x is going to be at -3 and a 3. So -3 and it'll end at 3. So our x minimum, our x max. And then our scale, we went by 3/4. So I'm just going to put 0.75. Okay, that's the same as 3/4. Our y minimum, I'm going to go ahead and include -2. And then we don't need to go as high as 2. We know that our highest value was 2. I'm sorry, I think I meant to say 6. We don't need to go as high as 6. We know our highest value is 2. So I'm just going to say, I'll just do 4. Okay, now graph. And something went wrong. And I didn't double check, but you could tell my red one graphed correctly. Something happened in my blue, so I'm going to check what I did wrong with my blue. Okay, so here we go. Y equals, and I can already see it. Do you guys see it? I put the x in the denominator instead of the numerator, so let me fix that. So delete it and then put the x on top. Okay, now it should graph correctly. It was like 2 different graphs. There we go. And it should look exactly like what we have, see, going on. Okay, just notice it stops and it keeps going, and it stops and starts at the same place. Okay, the blue one is the one we graphed. The red one's the parent. So now if you notice, what's the difference from the parent to this one? It shifts up 1 unit, okay? So hopefully I explained the shifts enough that you guys can graph it on your own. Again, you can get all the stuff without a calculator and then just use a calculator to verify that you have it correctly, okay? All right, guys, I think you have enough where you can do some on your own. So let's move on to the next part.